Okay, so let's continue with our next video in our coding exercise series. And in this video, we will solve the problem non-divisible subset, which is on the hackerrank.com, and it is under the medium category. All right, so just a second. Okay, so let's read the question. Uh, to solve this question, like first we need to understand because the code is very easy, but first we need to understand the logic. If we know the logic, then anyone can write the code. So given a set of distinct integers, so they said we have given some array where the distinct integers are given, right? So as an example, we have given s 19, 10, 12, 10, but you could see these are not distinct. So the example given in this question is wrong. So ideally it should be only 110 because the question says you have two, is the set of distinct integers, but which means two numbers can't be repeated, right? But here 10 and 10 is repeated. So this example is wrong, but you don't need to worry. Whatever the example we will cover here, I have removed that 10. So given a set of distinct integers, print the size of a maximal subset of S. So we need to print some size. So you need to print some integer. So if you see the return, you need to print some integer. Okay. Size of subset of S. Okay. We need to take some subset. Okay. Where the sum of any two number in S is not divisible by K. Alright. So if K is equal to 4, you need to create some subsets. All right, so maybe you create one subset by putting some elements, then create some another subset by putting another elements. But you need to create a subset in such a way that if you add any two number like 10 and 12, all right, or maybe 10 and 25, or maybe 25 and 12, the sum for any two numbers should not be divisible by 4 or the k. All right, so which means you need to test all the permutation and combination. And once you created all the subset, and then you need to find, okay, what is the maximum length of subset. So maybe one set you have created just for two element, one set you have created for three element, one set you created for four element. All right, which is satisfying this condition. So if you go with the brute and force approach, you need to create first all subset. You need to check all the combination, okay, whether if I am add two numbers, will it's divisible by k or not. That is like even time consuming and a very difficult approach as well. Okay, so let's, before jumping into the code, let's try to solve it using pen and paper. Okay, so let's suppose you have given this array 19, 10, 12, 24, 25, 22, and k is equal to 4. So this is S array, this is k is equal to 4. So you need to create a subset from this S array in such a way so that sum of any two number should not be divisible by k. All right, so 1 second. All right, so it should not be divisible by k. Okay, so what we did is, okay, we start creating a subset, right? So we start creating a subset. So let's suppose we start creating a subset. We iterate over this array as we found first element, so we just put first element 19. All right, and minimum we need two element because the question said the sum of two elements, right? So we put 19. Okay, then we go to the another element 10. First we check, can we put 10 in the subset or not? All right, so can we put 10? So 19 and 10, 29. Is 29 divided by 4? No, which means we can put the 10 as well. Okay, so we get another. So now our subset contains 19 and 10. Okay, now let's check the another element. Can we put 12? Because we need to find the maximum length of the subset, right? So can we put 12? Okay, let's try to put the 12. So if we put 12, the question says sum of any two elements, right? So if you put 12, you need to do the sum with 10, you need to check the sum with the 19. So if you do 10 plus 12, 22, is 22 divided by 4? So answer is no. So which means you can put, but we need to add with the 19 as well. So 19 plus 12, uh, 19 plus 12, you can do the calculation, right? So 19 plus 12 is 20, sorry, 19 plus 12, 31. Is 31 divided by 4? The answer is no, which means you can put the 12 as well. Okay. So till now you have three elements. Okay, let's check the fourth, 24. Now, if we try to put 24, whether we can put the 24 or not, we have to check. So if you put the 24, you need to check if sum of any two element is divisible by 4 or k, then you can't put. So let's try 24. If you put 24, then 12 plus 24 is equal to 36, which is divisible by 4, which means you can't put the 24, right? Okay, so let's try 25. So if you put the 25, 19 plus 25 is equal to 44, which is divisible by 4. So which means in this subset you can't put the 25. Maybe in some another subset you can put that, right? Now let's check 22. Can you like place the 22 in this? So 10 plus 22, 32. So 32 also divisible by 4. So which means you can't place the 32 in the subset. So you got one subset which has length 3, but whether this is the maximum subset or not, we don't know, right? Because right now we have only created one subset. Okay, now let's try to create another subset. So earlier we started with 19, now we will start with 10, right? So let's start with 10. Can you place 12? So the answer is yes, because 10 plus is 22. 22 is not divided by 4. Okay, can you place 24? Because we started with 10, right? We started with 10, so we placed 10. Then because earlier we started with 19, right? So from 19, we checked all the elements, 19, 10, 12, only three elements can be put. Now let's try with 10. Can we put, okay, the minimum element should be 10, okay, 10. Can we put 12? So the answer is yes, because 10 plus 12 is not divided by 4. Can we put 24? So the answer is no. 12 plus 24 is equal to 36, because you already put 12, right? So now you can't put the 24, because 12 plus 24 is 36, so which is divisible by 4. But you need to create a subset in such a way so that sum of any two elements should not be divisible by k. So you can't put the 24. Let me change the cursor 1 second. Let me change the cursor. Okay, so you have put 12, you have put 10, you have 10, 20, so you can't put the 24. Okay, can you put the 25? So the answer is yes, because 10 plus 25 is equal to 35. 35 is not divisible by 4. uh, this is 37. 37 is also not divisible by 4. So yes, you can put the 25 as well. Can you put the 22? So 10 plus 22 is equal to 32. 32 is divisible by 4, so you can't put the 32. So you have created one more subset, 10, 12, 25, but this is also of length 3. So it doesn't matter whether you consider this or doesn't matter whether you consider this, because both are of same length. In the question it is mentioned you need to find the maximal subset. Just we need to print the length, right? I don't need to worry, okay, what all element it contains. I just need to worry what could be the maximum length, right? So either I can take this or take this, doesn't matter, right? So similarly you will create the another subset, because till now we have created two subset, right? And both are of length 3, but we don't know whether there is any subset which is of length 4 or maybe which is of length 5 exist or not. So maybe this time you will start with 12. All right, all right, so you will start with 12. Can you put 24? So the answer is no. Can you put 25? So the answer is yes, so you put 25, right? So you put 25 here. Okay, so can you put 22 here? So you will do the calculation, like, so 12 plus 22, 34. So 34 is not divisible by 25 plus 22. So 47. So 47 is also not. So you can also put the 22. So still you get the three length only, right? So still you get the three length only. Doesn't matter whether you consider this, doesn't matter whether you consider this, either consider this, we are getting the three length. Now let's start with 24. Now, irrespective of like whether you start with 24, 25, 22, maximum you can get the three only, right? So the final answer is three. So we have the solution. Okay. So this is the question which is being asked, and we have solved using pen and paper. But are we going to solve in this way? This is the brute force approach. I have told you. Just iterate, pick one element, put into array. Can you put the another one? Can you put the another one? Check for all the instances. So basically you are iterating loop, one loop, uh, pick with 19, and then this one, then 10, then another one. So basically I scare, right? but one more loop where we are trying to add all the elements. All right, because before putting, you need to add with all the elements. If you put 10, you need to add with 19. If you put 12, you need to add with 10 as well. You need to check with 19 as well, like whether. So one more loop basically to do the addition with all the elements, whether sum of any two element is not divisible by k or not. Basically, the new element. So basically, I cube. So which is not even, you can write the code, but this is not going to be accepted by the hacker. You will get like a time error, right? Okay, so what is the another approach? So let's try the another approach as well, right? So at hopefully you understand the question, right? What is being asked? Okay, let's try the another approach, or not approach. Let's try the another example. So let's suppose you have array S. So S has some element 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 till 23, right? So we have some element, and I have take two cases here. So let's say k is equal to 7 and k is equal to 8. So this is two different example. So but the input array is same, and k is equal to 7 is k is equal to 8. All right, so like k is equal to 4. So k, what is k? K means when you create any subset. All right, so the sum of any two elements should not be divisible by k. All right, so if I create any subset, the sum of those two elements, any two elements, should not be divisible by 7. Similarly, here, the sum of any two elements should not be divisible by 8. Okay, so here we have like so many elements like 1, 2, 20. It could be any elements like 100, 200 elements. Okay, if you have k is equal to, if you have k is equal to 7, right? Okay, you have the k is equal to 7, right? So irrespective of the number of elements, right? Irrespective of the number of elements, what are the possible remainders you can get? So the only possible remainder you will get is equal to 0 to 6, because after 6 or after 7, any number, right? Any number in the counting should be divisible by 7, because 7, then 8, 9, 10, 11, 12, 13 is should not be divisible, then 14 will be divisible, right? Similarly like this. So what we will do, we have the k is equal to 7. So what are the possible remainder? 0, 1, 2, 3, 4, 5, 6 are the possible remainder. Okay, but within that remainder, what all the elements we can place? So okay, if k is equal to 7, if k is equal to 7, the remainder will be, can be 0, because some element can be completely divisible by k. uh, so currently I am not creating any subset. I am not even checking whether the sum of two element is divisible by k or not. That is the another part of the story. All right, so that is another part of the story. I am just whatever this S array, right? Because one approach is sorry, uh, one second, let me zoom out. So one approach is like iterate over all the elements. So we are trying to figure out some another approach. All right. So I have just divided this element into some, okay, some subset. All right. But these are not the subset which I'm going to consider. This is just like to make things easier. If k is equal to 7, what can be the remainder? So remainder can be 0, remainder can be 1, remainder can be 2, remainder can be 3, remainder can be 4, remainder can be 5, remainder can be 6. Similarly, if k is equal to 8, what can be the remainder? Remainder can be 0, 1, 2, 3, 4, 5, 6, and 7. All right. So 8 can't be the remainder, right? Because if it is 8, then it is easily divisible by 8, then the remainder will be 0. So 0 to 7 will be the remainder. Okay. Now just iterate over all the elements, okay, and try to place, if you have one. All right, so what we are going to do is, we are going to iterate over all the elements. So I pick one. Okay, uh, if I take one, what will be, and if I divide by 7, what will be the remainder? Remainder is 1, so which means I am going to place 1 here. If I place 2 and if I divide by 7, what will be the remainder? Remainder will be 2. It means I am going to place 2 here. So 1 here. So 1 here. and 2 here. Then 3. If I divide 7, if I divide 3 by 7, the remainder will be 3. So if I divide 4 by 7, then the remainder will be 4. If I divide 5 by 7, the remainder will be 5. If I divide by 6, if I divide 6 by 7, then remainder will be 6. All right. And if I divide 7 by 7, the remainder will be 0. So that's why I put, because these are the remainders, then I put 7 here. Then 8. If I divide 8 by 7, then remainder will be 1. So I am putting the 8 here. Similarly, 9. If I divide 9 by 7, 7 minus 7, the remainder will be 9 minus 7, 2. So which means 9 should be come here. 10. If I divide 10 by 7, 7 minus 7, 10 minus 7, 3. So which means it should be come here. So similarly, we have placed all the elements here. Okay. Now, now come to the actual question. So question says you need to create a subset. All right. So let's try to create a subset. All right. So whatever the subset we have to create, we need to take the elements from this subset, or now you can say from this subset, right? Okay, let's start from 0. Let's start from 0. Uh, I have picked 7. Can I pick 14 and 21? So the answer is no, because the subset is, I need to create a subset in such a way sum of any two element should not be divisible by 7. So if I pick 7, I can't put 14 here because 14 plus 7 is then 21 and 21 is divided by 7. So I can't put 14. Similarly, I can't put 21 because 21 and 7 is like 28, which is divisible by 7. So you can't put 21. All right. So either you can, when you create a subset, either you can put 7 here, or either you can put 14 here, or either you can put 21 here. Doesn't matter. All right. Similarly, like, so 1 second. Similarly here, right? So either you take 19, 10, 10, 12, or 10, 20, 40. The length is like remaining same, right? Okay. So now, irrespective whether I create a subset, because now I'm creating a final subset. So because I have to check, okay, what all elements I can pick the maximum, something like that. Okay, 7, 14, and 21. If I trying to create a subset, doesn't matter whether it start with 7, doesn't matter with start with 14, doesn't matter with start with 21. If I create a subset which has 7, then that subset should not contain 14 and 21. So anyhow, only one element, right? If I create a subset which start with 14, right, I can't place 7 and 21 in that. If I create a subset which start with 21, I can't place a 7 and 14 in that subset, right? Because if I place that, then the sum of two element is divisible by 7, which is going to violate our ask, right? So it doesn't matter whether you create a subset which start with 14, right? So let me put here, or maybe some another subset which start with 21. All right, we start with 21. So right now we have three possibilities, right? But all the three has only one element. All right. So so these three finish. Now let's check the another one. So by looking at this, so what is the thing coming to the mind? The thing is, if 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 any element divisible by 0, right, or you can say whatever this frequency array or this frequency thing we have created, if remainder is 0, you can maximum place one element. All right. So there is no need to check 14. There is no need to check 21. All right. Or if you start with 14, there is no need to check 7. There is no need to check 21. Similarly, if you play start with 21, there is no need to check 14. There is no need to check. So basically, you are saving a lot of time. Earlier in previous approach, all right, we we have not created this remainder array and we have to check all the elements, right? But in this case, if you start pick 7, no need to check 14, 21. So basically you save some time, right? Okay, now let's pick 1. So if you pick 1, right, so if you pick 1, all right, okay, so the array is 7, all right, okay, uh, 1. So we have k is equal to 7, right? So k is equal to 7. K is equal to 7. Uh, 7 can be divided into two things, 1 and 6. So 6 plus 1 is equal to 7. And 1 has this element 1, 8, 15, and 22. And 6 has these elements 6, 13, and 22, 20. If I place here 1, I can't place 6 here. I can't place 6 here. Because if I place 6 here, 6 plus 1 is equal to 7, which is divisible by 7. All right. So which means if I place any element, if I place any element from one array, then I can't place any element from 6 array. Or if I place any element from 6 array, I can't place any element from one array. All right. But which one is you are going to take? So I am going to take the one which has the maximum length. So because eventually I need to create a subset which is of maximum length. So I can put here 1. I can put here 8. I can put here 15. Right. I can put here 22. I can put here 22. All right. So this thing I can put. Now you can add like 8 plus 1, 9. Right. 1 second. And 8 plus 7, 15. Like, and you can like 22 plus 1, 23. 22 plus 7, 29. You can add any two number. It is not going to be divisible by 7. Right. But just in case, let's suppose, no, I don't want to take the 1, 8, 15, 22. I want to take the 6, 13, 20. Okay, take that. So you create a subset where you have the 7, then 6, and 13, 20. The length is only 4. Here the length is 5. Our ask is you have to create a subset which has the maximum length, right? So which has the maximum length. So eventually I need to take that subset which has the maximum length. So let me rub this. Okay. Okay. So now, so here, now we have 7, we have 8, we have, sorry, 1, 8, 15, and 22. All right. So we have created this subset. All right. Because if it is 7, you can take the element either from 1 or either from 6, but which one you need to take, what you can do is, okay, which has the maximum length. So 0 we have covered. All right. Now 1 we have covered and 6 we have covered. All right. So you can see now with this approach, just we have uh, figured out which element uh, come into which remainder. You don't need to iterate over most of the elements. All right. Okay, now let's pick 2. So now you have the 7. All right. So if you pick 2, the other element will be 5. All right. Okay. If you pick 2, all right. So you can put these elements like 2, 9, 16, 23, or you can put this element 5, 12, 19. But you can't put one element from here and one element from here. Basically, if in a subset anywhere you found 2, 9, 16, 23, then you can't place the 5, 12, and 19, because if you put 2, then you can't place the 5 because 5 plus 2 is equal to 7. If you place 9, then you can't place the 12 because 12 plus 9 is equal to 21, then it's divided by 7. All right. Similarly, like 23 plus 5, 28, you can't place that, right? So out of 2 and out of 5, you can place only like either you can place the elements from 2 or either you can place the elements from 5. So which one you are going to take? So I am going to take the 2 because the 2 has the maximum length. All right. So because the 2 has the maximum length, so what we are going to take is we will put here 2, 9, 16, 23. All right. So you have placed that. So now 2 is also done. 1 second. Let me rub this. So 2 is also done, 5 is also done. Okay, now we have the 7. So if I pick 3, the other will be 4, right? Okay, can I pick the element from 3 or can I pick the element from, doesn't matter because both has the length 3, right? So either you place all the elements from 3 or either you place all the elements from, uh, one second. So let me pick 3, 10, and 17. So what is our length? So all done. All right. So we have iterated over all the elements, because if you place 3, then you can't place the element from the 4, because 4 plus 3 is equal to 7. 11 plus 3 is equal to 14, which is 10 plus 4 is equal to 14. So basically you can't do that, right? 17 plus 4 is equal to 21. So now we just need to calculate the length of this array. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right. So the answer will be 12. All right. Okay. Now let's try the uh, another like example. Same subset S, but now instead of the 7, we have the k is equal to 8. So what's the approach? So let's iterate over all the elements. Let's create a remainder count. All right, a remainder count, and let's put, okay, 1. If we divide 1 by 8, all right, then the remainder will be 1. So you need to place 1 here. Similarly, 2 should be placed here. 3 should be placed here. 4 should be placed here. 5 here. 6 here. 7 here. And 8, if we divide by 8, then remainder will be 0. So 8 will be 8 here. Then 9 should be here. 10, 11, 12, 13, 14, 15, 16 should be here. 17, 18, 19, 20, 20, 21, 20, 24. Right. Now, we have to start from 0. Right. Uh, if the this remainder is if completely divisible by 0, all right, if the remainder is 0, then you can't place all the elements. So you can place only either 8 or either 16 or whatever the element. So we can take only one element. All right. So that's why you have taken only one element. All right. Okay. Now, because similarly here, like 7, 14, 21, you have only take one element. I have not placed 14 and 21, because 7 plus 14, 21 plus 7, 28, it's going to violate our ask, right? So if it is 0, if the remainder is 0, then whatever the elements in that subset, you can only place one. Either 8 or either 16, doesn't matter, right? Now let's go with the another one. If you take the one, all right, okay, let me take the color. So we have the 8 is k. If you take the one, all right, what is the another 7? So which means either you can take all the element from 1 or either you can take all the element from the 7. But both has the 3 length. So I can place here, let's say 8, 1, 9, 17. All right. Now let's go with the another one, 2. So if I place 2, either I can place the element from 2 or either I can place the element from the 6, because I can't place the element from the both. So let me place the element only from the 2. So 2, 10, 18. All right. Now let's go with the 3. So either you can place the element from 3 or either you can place the element from the 5, because both is of length same. So it really doesn't matter which element you are going to put. So 3, 11, 19. Okay. Now 4. So that's why I covered this question. The another example, 4. So now you have the 4. So 8 can be divisible by 4 and 4, right? Right. So which means, like earlier what we are doing is, so maximum of 1, maximum 7, right? But here both are same. If you do maximum of 4, it will be same, 4, 12, 20. But if you place all the elements of 4, 12, and 20, uh, You can't, because if you place 4, then you can't place that 20, because 20 plus 4 is equal to 24. If you place 4, then you can't place that 12, because 12 plus 4 is equal to 16. So which means if you come to this situation where after dividing the elements are equal, then again you need to place only one element. So 4. So this is our final array, and the length will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the answer will be 11. All right. Okay. So this is the approach. Now writing the code is much easier. So let's write the code. To write the code, uh, what we need to do is you need to create the. Okay, one more thing. One more thing. 1 second. Let me rub this before writing the code. One more thing. So here, like when I say let's create this array or something like that, 0, 1, 2, 3, 4, 5, 6. Do we really need to store these numbers 7, 14, 21, or just store the count? Right, because eventually we need the count, because we take, okay, can we take the elements from 1, and or can we take the element from 6? All right, so I said, okay, what is the who has more length? All right, so I really don't care whether it's contain 15 or whether it's contain 16 or whether it's contain 13 or whatever it is. What I just really care is which has the maximum length. So instead of storing all these elements just to save the space, all right, so in front of 0, instead of storing 7, 14, 21, what I can just store is just a single integer number, that is 3. 3 means the length of that array. In one, in front of 1, I can just normally store the uh, 4. Similarly for 2, I can just normally store the. All right, so basically what we are going to do is, let's say we have 7. All right, so what could be the remainder? 7 remainders. 1 second. So let me place 0 first, because we don't know how many count we are going to place. So right, but what are those indexes? So this is the 0 index, this is the first, this is the second, this is the third, this is the fourth, this is the fifth, this is the sixth. All right, and in front of 0, you are going to put 3. In front of 1, you are going to put 4. In front of 2, you are going to put 4. In front of 3, you are going to put 3. In front of 4, you are going to put 3, 5, 3, 6, 3. All right. So basically, we are going to follow this approach. All right. So let's jump to the code. So you need to create some array, right? So let's create an array, remainder count. Okay. And what could be the length of that array? All right, so whatever is this k, that will be the length, because whatever is the k is 7, then 0 to 6, which is length 7. If k is equal to 8, then 0 to 7, which is of length 7, right? And initially, because you don't know in front of 0 how many elements you are going to put, in front of 1 you are how many elements you are going to put, right? So initially, let's place all the 0 of length k. All right, so you have created uh, a array of length k. All right, now for I in S. Now what you need to do is you need to iterate over all the elements to check. Okay, one, this one. All right, where should you place? Either you place in front of 0, or either you place in front of 1, either you place in front of 2, either you place in front of 3. All right, so you found 1. All right, so where, like, you found 1, that is only just one element, right? So where it will come? It will come here, right? All right, it will come here on the first index. So let's find the index. How we are going to find the index? So whatever the element, I divided by k, modulus k, so it will give you the remainder. So basically I is equal to 1, 1 modulus 7, which is going to give you the remainder 1, which means this one is going to go at the index 1. So what we will do is remainder count of index plus equal to 1. Currently it is 0. So let me show you again. Initially we place all 0 because we don't know until unless we are not going to iterate. So now let's iterate. So we found 1. We know 1 should be come here, right? Now we found 2. We know 2 should be come here. We found 3. We know 3 should be come here. We know 4. 4 should be come here. We know 5. 5 should be come here. We know 6. 6 should be come here. 7. 7 should be come here. Basically the count. All right. Then 8. All right. So 8 modulus 7. 1. So index is 1. Right, so whatever the element on 1, we are going to add plus 1, so which is 2 now. So now 1 contains 2 element 8. Similarly 9, so 1 plus 1 2. So similarly you are going to update that. All right, so there are two ways: either you can store the number of elements or just store the length. So currently we are storing the length, so you have the remainder count, you have created that. All right, okay, so this step is completed now, and you have created this array. Right, okay, now what's the next step? So next step is you have to start with 0, you have to start with 1, you have to start with 2, you have to start with 3, right? So if we start with 0, like whenever we start with 0, we only take one element, right? Because we know if it is 0, which is completely divisible by k, you have to take only one element, right? Doesn't matter 7, doesn't matter 8, you are only taking one element, right? So which means start with uh, remainder 0. All right, okay, so the result is the integer which you are going to return. Result will be minimum of, because you need the minimum. All right, because if it contains 0, all right, if it is contains 0, then you can't put anything here, because maybe there is any element in this which is not even completely divisible by k, right? So you can't place anything here. So it maybe here you have the 0 as well. All right, so you can't take any element from that, right? So minimum of remainder count of 0 comma 1, right? So let's suppose the remainder count of 0. 1 second, let me again correct that. So here let's suppose after all the calculation, we found this 4 4 3 3 3 3, right? So minimum of 3 and 1. All right, so remainder count minimum of 3 and 1. So which is 1? If it is 0, then minimum of 0 and 1 is 0. So basically you have, because we are not going to store this element, because we, like, you have two approaches. Like similarly in this case, either you store all this number or either you just store the count. All right, if you want to just some space, just store the count, right? Similarly here, either you store all this number, now even you don't have the number, right? So I just worry about the length. All right, I need to return the length, so I really don't care about the numbers, what number it contains, because maybe the another array of same length. All right, okay, now we have done this. Now iterate over remaining remainders, but till half. Okay, why I mentioned it till half? Because if you, okay, we already cover 0, because 0 default we need to cover. So you need to start with the 1, right? So you need to, for I in range of, you need to start with the 1. But if you start with the 1, when you take 1, do you need to take 6? All right. No, because if you already go 1 and you already check whether you need to take the maximum of 1 and 6. So when you reach 6, are you again going to check whether you are going to take maximum 6 or 1? No. All right, because you already checked that these three element. So basically you need to check the half of the length. So half of the length and plus 1, because in the Python range, the last element is not considered, right? So k divided by 2 plus 1. So you need to iterate over half. Similarly, you need to iterate over half only till 4. You are not going to check the 5, 6, 7. Similarly, you are iterate over half only. Okay. Now, what's next? What's next? So, what you are normally doing? So, you are putting result plus equal to whatever is in the result. So, let's for result currently contain one element only, right? One. So whatever is in the result, you are taking the maximum of remainder count, maximum of remainder. So let's suppose you start with the 1, right? So you will check maximum of 1 and 6. All right, so maximum 1 and 6. So maximum of I and k minus I. All right, this is you are taking and you are returning the result. But here is a one catch. So this is normally you are doing, right? So when you start with the 1, so maximum of 1 and 6, then you the 2, so maximum of 2 and 5, basically 2 and 7 minus 2, 5, k minus I, right? Then 3, then this, and then like uh, we already cover the half, right? So we already cover the half. Okay, because okay, so now you have done that, but here is one catch. So this is the catch, right? Because if k is equal to 8, then you need to consider this situation. What is this situation? This situation is because you can't take the maximum of 4 and 4, right? So if I not equal to k minus I, so if I is equal to 4 is not equal to k minus I, if I not equal to k minus I, if these two numbers are not same, then only you can apply this solution, like maximum of, right? So which means if I is k not equal to I, then only you can apply the solution. Else else you are just going to take the one element, whatever is in the result, you will add the one element, and anyhow you are returning the result. So that's it. Let's try to run the code. If there is an issue, sample test case has been passed. Let's try to submit to test all the test scenarios. So all the test cases has been passed. All right, so the question is in the medium category. If you go with the brute force approach, that is this approach. 1 second, where is that? Like this approach, which the example which we have covered earlier. This approach, like start with 19 and then check each and every elements. Then even you can do that. It's also going to work, but it's going to work for maybe couple of examples. For large length, it going to fail, maybe time limit exceeds, right? So the second approach is this one. As soon as you understand the approach, okay, how you are going to do that, right? So you could see writing the code is not a big challenge. Writing is like, but is we are not writing anything very much complicated codes, right? So because you know how to create a frequency index array, okay, because you have to check all the elements. Okay, I have to check all the elements from my ins. Okay, but which element I need to pick? First I need to find the remainder. Okay, let's find the remainder. Right. Okay, now this is the remainder. Where it will go? Okay, there it will go. So you have created that. So Either you store all the elements, maybe at index count 0, store a tuple here, right? So maybe, sorry, maybe instead of length 3, you can store 7, 14, and 21 in a tuple or set or anything like that. It's up to you. Like how in my case, I have stored the length just to save the space as well, right? So yeah, so once you created that, and now we already iterate. Okay, if you if it is 0, then you can't take all the three elements, you have to take only one element. So we already done that. If it is 0, you have to take only one element or the minimum, because if it is 0, then you have to take the 0, you can't take one. Then you need to iterate over the remaining. Now even for the remaining, you can iterate over till half, because when you consider 1, you already consider 6, right? So you can't iterate 1 to 6, because when you reach to 6, then you say, okay, 6 is here, then 1 is here, then you again found. So you are ending duplicate elements into the subset. So which means you have to go with the half. So I 1. So anyhow, 0 already considered, you need to start with the 1. So we start with the 1 until half. Okay. So we just normally put here, okay, maximum of, because we need to get the maximum count. Okay, whether I take 4 or 3. Okay, I will take the 4 one. But here in case of 8, we have some catch, because when we reach the 4, we divide 4 or 4, right? So whether we'll take the 4 or 4. So if I and k minus I is equal to same, then you need to take only one element. So just we put some extra if else condition, because if you are not going to put this condition and just put result is equal to max and return, maybe half of the test cases work, but maybe 1, 2 test cases will fail, right? So we place this condition as well and then return result. So that's it. That's the end of the video, and thank you.